Good afternoon, ladies and gentlemen. Welcome to Math 20-1, Chapter 5 and 6 review before the final exam or your retest. Anyway, so we're going to start with Chapter 5, Inequalities and solving graphically. Anyway, so inequalities, if I ask you to go x minus 2 is greater than 3 and put that on a number line, you, of course, try to get x all by itself. So x is greater than 5. So notice no numbers on the number line, so you have to go 5. And notice it's a hollow dot because it's x is greater than, does not include 5. And I would shade everything going to the right that way, make it nice and big. Now, tricky one, 6 minus 2x is greater than 4. Well, first things first, you want to get x all by itself, so subtract 6 from both sides. So minus 2x is greater than or equal to minus 2. Then you divide both sides by minus 2. And what happens? Well, x is less than or equal to 1. The greedy fish changes direction when you multiply or divide by a negative number. So what happens here? Instead of being x is greater than, it becomes x is less than or equal to, it becomes a solid dot. We call that 1. And we have the arrow going to the left like that. Okay. Now, next thing would be quadratic inequalities. So I'd ask you to solve this, and you're going, you can't easily. So what do? You treat it, well, x squared plus 8x plus 15 is greater than 0. You graph it like, or you draw it like that, or you go to Mr. Graphing Calculator. And yes, there's a way to do this on your graphing calculator, but I can't remember if you shade above or below. So what I want you to do is find the critical points. Now, x plus 3 times x plus 5 would be greater than 0. So x plus 3 minus 3. So x equals minus 3 is a critical point. X plus 5 x minus 5 on both sides, x equals minus 5. So these are my two critical points. So I go minus 3, minus 5, and I go, what's going on here? Now, I know from previous drawing graphs, y equals x squared plus 8x plus 15 will open up like that because it's plus x squared. Now, do I know exactly where the vertex is? No, I can figure that out in about 2 seconds, or I can graph it. Now, what I need you guys to do is figure out where is this graph bigger than 0? That is, y is greater than 0. So looking at the graph here, y is greater than 0, or y is positive when it's above the x-axis. So the answer is x is less than or equal to minus 5, x is greater than or equal to minus 3. So that's doing it graphically. Now, can you do it algebraically? Yes. Well, actually, let me show you how to do it graphically. That's easy. Sorry. Actually, I should show you as I do this. So it is x squared plus, brain fart, 8x plus 15 plus 8x plus 15 graph. And there we go. Now, I look at my table of values. When is this? Okay, second table set. Start at 0. Go back to my table. All right, so when is this positive? When x is less than or equal to minus 5, and when x is greater than minus 3. In between, it's negative. Okay, see that? Now, this is where I'd be circling x is minus 4, y is minus 1, but this smart board won't let me. So we can go to the table of values. So we went like minus 6, minus 4, and minus 2. We got minus 1. When x is 6, we got 3. Oh, okay. Or positive number, negative number, positive number. Okay, so you can do it graphically, or you can look at the table of values, which is that technically algebraically? I don't know. Anyway, so that is solving inequalities. Now, graphing quadratic inequalities. You'll notice we're using the same quadratic so that you don't have to go back and keep plugging numbers into your calculator. Now, I just graphed this, so I know when x is minus 3, 1, 2, 3, and minus 5, vertex is here, over 1, up 1, over, sorry. I know from looking at my data table back here, my vertex is at -4 and -1. Here. Over 1, up 1, over 2, up 4, over 2, up 4, over 3, up 9, 3, 6, up here. All right. Now, since this is greater than, not equal to, we use a dashed line to indicate we do not include the line. So to solve this, once again, we can go to our data table. Or what I would prefer is if you choose a point inside the graph and outside the graph. Now, my first favorite point is 0, 0. Because even I can handle this. Instead of y, it is 0 is greater than 0 squared plus 8 times 0 plus 15. 0 is greater than 15. No, doesn't work. So it should be a point inside the graph. Now, does it matter where? No. I'm going to choose down here -4 and 0 because I have a 0 there. I'd like to choose x equal to 0, but that's way the hell up there somewhere, and I'm not doing that. Sorry, it'd be way up here somewhere, x is 0, and I'm not going to try calculating that. Actually, I think it's 15, but anyway. Where was it? Oh, yes. So 0 is greater than -4 squared plus 8 times -4 plus 15. So 0 is greater than, that's 16, 8, 16, 24, but minus 32. 32 plus 15. So that is 16, 15, 31, greater than -1. Yes. So it's inside. It's greater. Now, notice this is less than, y is greater than. The previous example, y would be less than. But anyway, just point out, try the points that work. Since we changed the equation, the sign changed direction. It's inside is now what we're looking for, or negative. Okay? So you draw the graph. If it's a less than or greater than, it's a dashed line. Do not choose a point on the line. Choose a point inside and outside and check. Now, next bit is solving systems of equations graphically. So if I gave you a couple of equations like this, I'd expect you to solve it graphically. Now, y equals 2x squared, so that's 1, 2, 3, 4, over 1 up 1, over 2 up 4. Notice this is equal to, so it's a solid line. Now, the other equation is y is x plus 6. 1, 2, 3, 4, 5, 6. Oh, crap. From my crude graph, neither of these are nice points. X plus 6, enter, graph. Second, calculate, intersect, enter. Scroll over to the first one. Yes, yes. Second curve, guess, yes. I hit enter one too many times. My apologies, ladies and gentlemen. Yes, second guess. Second curve, yes, guess, yes. Minus 5.3. Did you color code this? 5.3. And I'm going to go to 1 decimal point because I can. I sometimes will go to 2 decimal places. If I wanted the exact values, we would solve it, and that's a different question. That's a different section. Minus 1.7 is a guess. Minus 1.7 is the actual answer. Okay, so that's solving it graphically. As I said, I'm just hitting the high points. Now, algebraically, this is a little neater. X squared plus 8x plus 15 equals x plus 6. You want everything on one side so it equals 0. So subtract x, subtract 6, subtract 6. So it becomes x squared plus 7x plus 9 equals 0. Now, Go ahead, try factoring that. You are not going to get a number, two nice numbers that multiply together to be 9 and that to be 7. They do exist. We just found the decimal approximations here, minus 5.3 and minus 1.7. So how do we solve this? We're getting fractions or decimals, the quadratic equation. Woohoo! Let's hear it for the quadratic equation. Now I'm going to do this one with you. That's minus 7 plus or minus square root. And once again, if you guys got this, really skip on to the next example. This is 7 squared minus 4 times 1 times 9 over 2 times 1 minus 7 plus or minus square root. Let me see, that's 49 9 is 8 minus 36 over 2. So it's minus 7 plus or minus square root of 13 over 2. Yeah. Once again, we get a radical that we can't factor. I was hoping if we got like, I don't know, 28 or something, we can factor and simplify. Anyway, negative 7 plus square root of 13 is minus 3.9 divided by 2 is minus 1.69722, yes. And I'll leave it to you to prove that minus 7 minus root of 13 divided by 2 is minus 5.3 something. So that's solving algebraically, and you would have to use the quadratic equation. The last, and I believe it is, oh no, keeps on going, my bad. The pain continues. The last one for chapter 5, radicals and equations and solving. I give you the graph of two equations. You've got to figure out the equation, and you've got to figure them out, what these answers are graphically and algebraically. Now, the red one is a parabola. We've done that before. A x minus p squared plus q x minus 1 squared minus 2. So that's pq down here. Okay, I should color code that. 1 minus 2. Now, we also have an x and a y value here. So every time we see x, we replace it with 2, and every time we see y, we replace it with 2, and we solve for a. Bring back nightmares, flashbacks, and get rid of minus 2 by adding 2 to both sides. So 4 equals a times 2 minus 1 is 1 squared, which is 1, which is a. So the first equation, y is equal to 4 times x minus 1 squared minus 2. That's the hard part. The straight line has a b value equal to 1, and my slope is over 1 and up 1, so that is y equals 1x plus 1. Now, I just showed you how to solve that graphically, and I just showed you how to solve it algebraically. I'm not going to solve this one graphically for you. You guys can plug that into your graphing calculator and solve. If you're having trouble with it, shoot me an email, and I will give you a hand with it. Now, chapter 6 is trig. Woohoo! Sine, cosine, all that crap. So, typical question, what's angle x? And you notice angle x is over here. We're given this side of this triangle, this side of this triangle, and this angle. Note this is a right angle triangle. This is the opposite side. What side do we have to solve for? Well, the side that's shared. This is the hypotenuse, which becomes the opposite of this triangle. So, opposite and hypotenuse, let me see, that is, sine of theta is opposite for hypotenuse. Now, that's the way it's, excuse me, written on your formula sheet. However, I think I showed you in class, did I show the grade 10? Anyway, let's just solve. So sine 42, no, I rewrote this. So I found a better way to rewrite this. Instead of writing it like this, I really want you to cross multiply. So opposite equals hypotenuse times sine of theta. Now, why? Because sometimes I forget if with this opposite hypotenuse, you multiply or divide, or what the heck you do. Anyway, so we have sine of 42, and we have our opposite side, which is 15, equals hypotenuse. So what do I do here? In order to find the hypotenuse, divide both sides by sine of 42 degrees. Mongo speak English good. And if you're old enough to get that joke, what are you doing in my class? All right. So 15 divided by sine 42 is 22.4. Oh, wait a minute. So I should be showing you this, shouldn't I? 15 divided by sine 42 is, oh, and that's same to you. 15 divided by sine 42 is 6. Sine 42, try this again. And that's the beauty of the TI calculators. You make a boo-boo, you can copy and paste. And there I am in radians. My apologies, ladies and gentlemen. I just made the classic beginner's mistake. I forgot to check my calculator. And I meant it. So let's try that again. 22.4. Now, no, you do not do the rounding off. I'm just writing as 22.4 because I'm not writing up the next whatever digits, 6 or 8. Now, this is the adjacent side. We've got the opposite side, and we're looking for the angle. So it's tan of theta. It's opposite over adjacent. Now, I do want you to rewrite this. Opposite equals adjacent tan theta. Why? Because I said so. So the opposite side is our hypotenuse, 22.4, equals our adjacent side, 11 centimeters, times tan of x. So tan of x is 22.4 divided by 11. Inverse tan of 22.4 divided by 11. Inverse tan 22.4 divided by 11, close bracket, enters 63.8 degrees. I'm going to call it 64 degrees. Now, sometimes I'll ask 1 decimal place, sometimes I'll ask 2 decimal places, but I would be specific. In this case, I don't care. Right? Now, exact values of the sides. Right. So, what do we got here? What do I mean exact values? Well, I want to find this opposite and this adjacent. So, and I have the hypotenuse given. So, opposite, let's find the opposite first because I can. Opposite hypotenuse and dealing sine theta, or the opposite side, so hypotenuse times sine theta. Now notice, and oh sorry, if we go back, this is on the quadratic coordinate plane, the opposite is my y value. So some people will talk about this y equals the hypotenuse times sine theta. In this case is 15 sine 30, which I know is 7.5. 15 sine 30, 7.5. How do I know that? Because I remember the exact value of sine of 30 degrees is 1/2. Just like I remember that the exact value for cos of 30 degrees is root 3 over 2, which is decimal approximation 0.866. Anyway, cos of theta is adjacent for hypotenuse, or adjacent hypotenuse cos theta, which is x, which is 15 cos 30 degrees. Now, I cannot do, now I talked about that in class, how it's root 3 over 2. I can't do that in my head, so I'm going to go 15 cos 30 and close bracket, just because 12.99, which I'm going to call 13. Okay? Now, next thing, For the point minus 5 minus 2 on the terminal arm of angle theta, what is sine theta, cos theta, tan theta, and theta? Oh, God, I hate these. I'm not a big fan of them either. Anyway, for the point minus 5 minus 2, minus 5 minus 2, that's our angle there. What is sine theta, cos theta, tan theta? Well, I went sine theta is y over r. Cos theta is x over r. Tan theta is y over x. Now, I can do y over x right away. Y is minus 2 minus 5, which is 2/5. Okay? Now, oh crap, what's r? Well, back here, and think of this as a right angle triangle. Minus 5 minus 2. What's the resultant? Well, we use Mr. Pythagoras' theorem and solve. Okay. So, grab Mr. Calculator. R x squared plus y squared. I've shown you the shortcut formula. Radius is the square root of x squared plus y squared. Minus 5 squared plus minus 2 squared. 25 plus 4. R is the square root of 29. And I will scream and throw things at the first person that calls this 5 point something. Okay, just as long as we're on track. So y is minus 2 over square root 29. Cos theta is minus 5 over square root 29. Okay. Now, I'm going to pause the recording here. I want you guys to grab your calculator. Tell me sine minus 2 over square root 29. Inverse cos minus 5 over square root 29. And inverse tan 2/5. Okay. So as I said, I'm going to pause the recording here. You guys figure out these angles. Then we're going to come back and talk about why your calculator's lying to me. Okay, ladies and gentlemen, welcome back. When I did this, I got these numbers, minus 28.1, 158.2, and 28.8. What the fudge pot? Well, here, I'm trying to get you to remember your calculator is, well, it's not lying to you. It's just an idiot. It's giving you two possible answers, and you have to figure out, or sorry, it's giving you one possible answer, and you have to realize there's a second one. For example, sine, Mr. Calculator is going minus 2 is y, and the radius is 29. By default, it goes to where the closer answer to the origin of the x-axis. So it's going over here, square root of 29 and minus 2. This is minus 21.8 degrees. Okay. Now, if you do a little bit of symmetry, you realize this is 21.8, and this is 180. So there is another angle in there. Well, there's several other angles, actually. But 180, 201.8 is the correct answer, but once again, Mr. Calculator is not giving you that answer. Cos of theta, minus 5 over root 29. The closest one to the x-axis is here. So there it's going, oh, that's 158.2. Then you're going, no. There's also this one down here. What was I? Oh, yeah, sorry. I'm saying be 158, sorry, cos of theta is 158.2 degrees, or the angle. Inverse cos of minus root, try this again. Inverse cos of minus 5 divided by square root of 29 gives you 158.2. Mr. Calculator is going, oh, that's right here, but there's a second one down here. So you go 360 minus 158.2, and you get 201.8. Now, tan of theta is doing the same idea. It's going x is plus 2, sorry, y is plus 2, and x is plus 5, so it's going up here in the first quadrant. You have to add 180 degrees to this to get 201.8 degrees, the second one down here. So just remember, Mr. Calculator isn't lying to you. It's just being dumb and lazy and giving you the first possible answer, and there's almost always a second. Calculators. All right. Now, second to last bit for trig, angle B, side C. You notice we've got side, angle, and another side. If it's side, 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 or side, angle, side, then we use cosine law. Here, I guess we have to use sine because we have the side and the angle opposite it. So we're looking for 4. We've got 4, and we're looking for angle B. So sine of B over B equals sine of D over D. Now your formula sheet goes sine of A over A equals sine of B over B. Whatever. If you can't figure out how to rewrite it, you have bigger problems than this. Anyway, sine of B over 4 equals sine of 49 degrees over 6. Sine of B equals 4 times sine of 49. And I should be putting this in brackets divided by 6. Okay, so 4 sine 49 close bracket divided by 6. And put it in brackets equals 0.5031. 0.50 brain fart 31. Angle B, sine minus 1, 0.5031. No, I'm not rounding it off. I'm just writing out the first 4 digits because I'm lazy. Inverse sine, inverse answer, close bracket. And yes, 30.2 degrees. Get in the habit of writing your close bracket just because sometimes some versions of the TI calculator hate this. So that's 30.2 degrees. Now, side C. Yeah, we have to use sine law again. So I'm going, that would be, let me see. Now, if we're finding side C, write the side on top. Now, do we use B or D here? Well, I would use D because we know it's, sorry. We know side D and angle D. We might have made a boo-boo calculating angle B. Anyway, sine of, oh, what is angle C? Oh, the easy question I completely forgot to do. Well, the 3 angles in a triangle equal 180. So 180 minus 30.2 minus 49. $100.8. Sine 49. So side C is 6 times, make that a little neater, Mr. Sutton. And yes, it does help to put it in brackets anyway, so 6 sine answer, close bracket, divided by sine 49. And here's where you get into trouble if you don't put in brackets. 7.81, call it 7.8. From my crude drawing, yeah, I believe that. Okay, so that's sine law. Now, side F, okay. All right, side F. All right, so here we have side, angle, side, so we can use cosine law. Now, there's 2 versions written on your formula sheet. A squared plus B squared, sorry, A squared equals B squared plus C squared minus 2BC cos A. That's for finding your missing side, so F. So rewriting that, we're looking for F, so that is G squared plus H squared, excuse me, minus 2GH cos of F. Now, I like doing this in steps, and I'll show you why. So this is 17 squared plus 10 squared minus 2 times 17 times 10 times the cos of 105 degrees. 17 squared is 289 plus 100. Now here, 2 times 17 times 10 times cos of 105 is minus 87.998, 88.00. That's minus minus, which becomes a plus. So that is 289 plus 100 plus 89. It's 478. .86, 21.9. So from my crude drawing, I tend to agree with that. It's about twice the length of the side of length 10, and it's noticeably more on the side length of 17. So yes, 21.9 is reasonable. Okay, see how that goes? Now, last question, angle D. What's this angle here? Well, that leads to the other version of the formula. Cos of A equals B squared plus C squared minus A squared over 2BC. And I'm going, if this is A, calling this side A, then we arbitrarily call, well, B and C we can leave the same. Anyway, I'm going to rewrite the formula. Cos of D equals B squared plus C squared minus D squared over 2BC. So B is, and this is the problem many of you guys had on the test. You got the B, C, and D mixed up, or B, C, and A mixed up. So you subtracted the wrong one and added the wrong one. Anyway, and plus 9.3 squared minus D, 7.4 squared over 2 times 6 times 9.3. Now this is why I want you to do it in steps, so I can go, oh yeah, so that is 36, 9.3 squared, 86.49, 7.4 squared is 54.76, 2 times 6 times 9.3 is, so 36 plus 0.49 minus 4.76 is 67.73 over 111.6. 0.6069. That's cos of D. Angle D, cos of minus 1 is 0.6069. Inverse cos inverse answer. 52.6. Okay. So that's how that goes. Yeah, that's the last question. Okay, so that's a quickie review hitting all the high points of chapters 5 and 6. Got any questions? Shoot me an email. Otherwise, work on the review questions, and I'll see you in class.